engine lubrication system. The internal combustion engine contains numerous friction parts. Friction wears them out and causes them to overheat. To reduce friction and remove heat, cars use a lubrication system. This system delivers lubricant to all friction parts. The most vital parts are fed with lubricant under pressure, while other parts rely on gravity and splash feeds. We will examine the engine's whole lubricating cycle. Fill up the engine with motor oil. The oil is drained into the oil sump along the available routes. In this case, it happens via the timing drive cavity and the dedicated channels. The oil is stored in the oil sump that has a dipstick attached to it. An oil pickup with an oil strainer is also housed in the sump. Start the engine. Starting the engine activates the oil pump, which draws in oil, creating pressure at the outlet. In this example, the pump is operated by a chain drive from the crankshaft, although a gear drive or the pump mounted directly on the crankshaft are also options. A pressure relief valve controls the limit pressure and opens when the safe permissible pressure is exceeded. It is mounted either on the oil pump or at the start of the oil gallery. Let's take a quick look at how some oil pumps work. You can see several gear pumps that act as oil pumps. They can feature either external or internal gear meshing. The gerotor pump, which has no crescent partition and one less tooth on the inner rotor, is one type of pump with internal gear meshing. Another variety is the variable discharge oil pump. Pressurized oil goes from the pump into the cylinder's block's oil gallery, having been cleaned of fine metal dust and other oil impurities by passing through an oil filter. If the filter becomes too clogged, the oil will pass through the bypass valve without being cleansed. So, replace the filter every time you change your oil. The filter outlet features an oil pressure sensor, but we'll talk about it later. The oil runs on along the cylinder's block's oil gallery towards the crankshaft's main journals, where it lubricates the main journals and its main bearings under pressure. This produces an oil coating that greatly minimizes friction. Following that, the oil flows through the crankshaft channels and lubricates the rod journals and its connecting rod bearings. Let's take a closer look at the crankshaft's oil passage. The pressurized oil is pushed out of the connecting rod bearings by the rotation of the crankshaft and sprayed all over the crankcase, lubricating the cylinder walls, pistons, piston pins, and partially the timing drive. This also generates oil mist in the crankcase. The splashed oil then runs down to the oil sump. Simultaneously, some oil flows through the oil gallery in the cylinder block and cylinder head, eventually reaching the camshaft journals and being pushed out to lubricate the timing drive, including its cams, tappets, and valve stems by gravity and splash feed. The oil then returns to the oil sump, and the cycle starts all over again. The system should contain at least one oil pressure sensor, which controls the system's functioning. Pressure sensors can be placed in different parts of the system, including downstream of the filter and at the far end of the oil gallery. Sometimes, the system features several sensors, for example upstream and downstream of the filter. When the oil pressure in the lubrication systems is low, a warning light illuminates on the dashboard. We looked at one of the most basic lubrication system designs. More complex systems may include oil temperature sensors, oil level sensors, and air or water-cooled radiators. Cooling radiators can also feature various coupling schemes. There are also approaches to improve lubrication and cooling of cylinders, piston, and piston pins, such as extra oil passages in connecting rods, oil holes at the bottom of connecting rods, as well as oil jet nozzles in the cylinder block. Lubrication is also required for some optional systems, such as turbocharger. Some control functions can be performed via the lubrication system. Thus, pressurized motor oil is essential for hydraulic lash adjusters, some variable valve timing systems, and timing drives hydraulic tensioner. To prevent any excess oil in the combustion chamber, pistons are outfitted with oil control rings that remove most of the oil from the cylinder walls, as well as valve stem seals that prevent excess oil from entering through the valve stem. Various gaskets and oil seals between the engine's stationary and moving parts aid in preventing oil from exiting the engine. Finally, keep in mind that oil changes are crucial since oil becomes contaminated over time, causing it to degrade. So, change your oil regularly. Prolonged use of dirty oil results in severe engine wear. This concludes our review. Subscribe to our channel for more videos. Until next time.